David Smith here with one more flipped classroom math lesson. 3 tips before we start. First, remember that you can adjust the playback speed faster or slower as you desire. Second, you can pause the video at any point to jot down some notes or write down some questions for our next class. Lastly, you could turn on the captions so you can read my words go by on the screen. Okay, today's lessons covers three different topics. We're going to take a look at inflation, annuities, and amortization. Okay, so first off, inflation. You probably already know what inflation is, but let's just put up a nice definition. This is the rate at which prices increase in an economy. And this year in 2022, 2023, we've actually been dealing with quite a bit of inflation lately, but it is coming down, so everybody's super happy about that. Because when you think about it, inflation is price increase, so that means things get more and more and more expensive. So that's generally not a good thing. So here we go. That's our definition of inflation. An inflation adjustment is changing a price due to inflation. And you've probably seen things like you're getting some stats that say prices adjusted for inflation. Because maybe 10 years ago, you might have paid $20,000 for a car, and a roughly comparable car today costs $27,000 because inflation has brought that up. The thing is that your wages have also had inflation, so they've come up. So $20,000 10 years ago is pretty much the same, has the same buying power as $27,000 today in that really rough example. Okay, so let's do an example problem. Here we go. We've got a rate of inflation, 4% per annum in an economy, maybe our economy. Given that inflation continues at the same rate for 5 years, find the percentage increase after 5 years. Okay, so this one involves just a little bit of critical thinking. The calculation is straightforward, but to set it up and figure it out, not so much. So pause the video and think about that. Okay, so if you figured out that it had to have something to do with this equation, you're right, because we have present value and future value. So if I knew the present value of some object and I expected inflation to continue at 4% for 5 years, I could use this calculation to figure out the future value of that thing, or the future price. This could be present price and future price. However, in this scenario, we don't have a value. We just want to know the percentage increase. So it's actually a little simpler. What we do is we don't need the present and the future value. This term here gives us the percentage increase because we're going to multiply this term times the present value to get that future increased price. So we're going to use the information in here to do a plug-in step with just this part. So what we're going to get is percentage increase, I'm just going to use an arrow for increase, is going to equal 1 plus R, which is 4%, over K times 100. Now, we don't have a compounding period in this. We're just running 4% inflation for 5 years. So this is just going to be 100. And then again, no K, we're just going to put in our 5. And that is going to give us our percentage increase. So go ahead and pause the video, crunch the numbers. Okay, so when I crunch those numbers, I get 1.22 for this deal here. Now remember, this is our R in our geometric sequence, right? If we're looking at it that way. The 1 here preserves the present value. The 0.22 is the actual increase, the percentage increase. So our percentage increase is 22%. Okay, let's do a price adjustment using inflation. So same scenario as that last example. We've got a computer game that costs $35 today. If inflation remains constant at 4%, how much will it cost in 1 year? So go ahead and pause the video, write your plug-in step, go ahead and solve and find out the new price. All right, let's see how you did. Here's my equation, standard equation. I'm not using K. I have my plug-in step, 35 times 1 plus 4 over 100. And when I crunch the numbers, I get 3640. So if inflation is 4% per year, a year later, this computer game is going to cost $1.40 more. Now, pause the video and do the same calc, but for 5 years. Okay, let's see how you did. Future value, present value, times 1 plus 4 over 100 for 4% interest. Now our exponent is 5. Crunch those numbers. Now I get $42.58. So over 5 years, that's going to increase quite a bit more. All right, let's take a look at the second item on our list for today, annuities. So an annuity is a little bit of a complicated financial instrument, and I've tweaked the definition that's in your book to make it a little bit more understanding. I hope I'm successful. So let's take a look. An annuity is a fixed amount paid into an account. So you might shovel $200 a month into an account, or you might shovel $3,000 a year into an account, but it's a fixed amount that's paid into an account in a regular way, and it's going to result in a predetermined total after a period of time. So as a retirement instrument, you might set up an annuity where you're going to throw $250 every month into this annuity for the next 30 years, and then the company that you're using is going to promise you that that's going to be worth a certain amount of money at the end of 30 years, regardless of what's happened in the economy, regardless of what interest rates have happened. So there's an internal interest rate in that annuity that they are guaranteeing you. Another way to deal or to think about an annuity is if you're trying to save up a certain amount over a period of time, and you're putting that money into an account with a fixed interest rate, you can set that up. Like say you want to buy a $100,000 house in 5 years, then you can use this kind of a thing to calculate what is the monthly payment you need to throw into that account. So after 5 years, you do have your $100,000. So let's do an example. Okay, so here's our problem. David wants to buy a $1 million yacht in 10 years. Now, this is really so not me, plus I don't think that's in the realm of what's possible for me, but let's just pretend like I'm like the richest teacher on the planet and I want to buy a $1 million yacht in 10 years. So what I do is I go out, I find an annuity that will pay me 4% per year for 10 years. Great. So now all I need to know is figure out how much do I need to put in at the end of each year so that at 10 years, that the bits and pieces that are growing at 4% plus all my contributions are going to end up being $1 million. Okay, so pretty simple question. Now this is one that we're going to answer with the calculator. The calculator has some pretty nice financial functions in there where you really only have to enter your variables to get that done. So I've written out the variables. There's 6 of them, 6 that we need to know, and then we're going to fill in the values based on our word problem. Now, there's one thing I didn't tell you in this problem. The interest is compounded annually, okay? So not daily, not monthly, not quarterly, but annually, okay? All right, so number of payments. 10 years, annually, he's going to make 10 payments. Each year, he's going to put in 1 payment, okay, for 10 payments total. Interest rate, we know, that's right here. That's 4%, and it's as a percentage. So you're not going to put in 0.04, you're just going to put in 4 for 4%. PV, present value, what's that going to be? 0. We're starting from scratch. We don't have anything in the account. We're building and growing the account. So that would be 0. Future value, that's the target value, and that's the $1 million. So we got $1 million as FV. Now these last two are a little weird. PMY, it's the number of payments per year. He's only putting in 1 payment per year, so that's 1. And then the number of times compounding per year is also 1. All right, so those are our variables. Now, let's jump over to the computer and see how that looks. Action. All right, so I'm going to use my TiNspire to find the yearly payment we need to throw in the account so that after 10 years, we have $1 million in there. So my first thing is I'm going to calculate. Now I need to go into the menus, and you'll notice that all the menus have numbers, so you can use those numbers on the keypad to access the menu. So 8 is finance, which is where I want to go. And then I want to use the finance solver, which is 1, so I'm just going to press 1. And here I am in the solver. So N is the number of payments. You can see I've already got 10 in there. I've done this calc before. Interest rate is 4. Present value is 0. Now, if I were doing this calc again, I'd want to make sure that I came into payment and I zero that out, because when you show up here, you won't know what that payment is. Future value is $1 million. Go down, one payment per year, interest compounded once per year. So I've keyed in all the information from the board and on my little cheat sheet here. So now I want to scoot back up and go into payment. So now that's the field that's going to show me what my payment is. And notice below it says, press enter to calculate payment. So I'm going to press enter. Let's start by taking a look at our result here. We've got minus $83,290.94. Why is it negative? Think about that for a minute. It's negative because we're paying it out. We're paying it into the annuity, so it's leaving us, so it's a minus number. That's why it's negative. Now, this is the amount total that we're going to put in that account every year. So as long as every year I put $83,209.94, at the end of 10 years, I'm going to have $1 million in my account. All right, the last of our three-part lesson. This time we're going to do amortization. And before we get into the definition, amortization is just the reverse of an annuity. The annuity, we wanted equal payments with a fixed rate so that we could build that thing up to a predetermined value at the end of a certain amount of time. Amortization just going backwards. You want to pay back a loan with equal payments with a fixed rate over a predetermined period of time. So typically people buy cars, they buy homes, maybe furniture, things like that are the typical things that people buy on loans. So let's check this out. Paying back a loan with a fixed interest rate and fixed payments. And I should say over a certain time. So here's our example. Donald takes out a $35,000 loan to buy a new car, a very common thing that people do. His interest rate is 1% per month. Okay, a little bit different than the way we usually express interest rate, but very valid. And then what we're going to do is try to figure out his monthly payment. Okay, and this is a 10-year loan, I believe. Let me check my notes. Yes, it's a 10-year loan. So let's just put that over here. 10-year loan. So very understandably, Donald wants to know, what's my monthly payment going to be? I'm borrowing $35K to borrow this car. I need to pay it off in 10 years at 4%. What's my monthly payment going to be? And the thing is that you want a regular payment so you can budget. If your payment went up and down and up and down, it could create some grief for you on a given month. So the next thing we do is we define our variables. And in this case, they're the same variables as we use for annuity. In fact, we're going to use the same function in the calculator as you used for an annuity. So here you go. N, that's the number of payments. 10 years at 1% per month. So we're going to make monthly payments for 10 years. So that's 120 payments right there. Interest rate. This is the yearly interest rate. So if we're paying 1% per month, we're paying 12% per year. So that's 12%. The present value. The present value of the loan is negative $35,000. I owe that much money, so to me that's a negative. So we're going to put minus 35,000. Payment, this is what we're trying to figure out, so we're going to have to put 0 in the calculator for that one. Future value, what's it going to be when we pay the loan off? It's going to be nothing, 0. This is payments per year, that's 12, and compounding per month, that's also 12. Okay, so those are the variables. Let's step over to the calculator and put them in. Okay, here we are at the TiNspire, and we're going to go ahead and put our variables from our calculation that we looked at on the board just a minute ago, and we're going to put them in the calculator and find out what our monthly payment is. Just to refresh, we borrowed $35,000. We want a constant monthly payment that pays that off in 10 years' time at a fixed interest rate. So, first one, number of payments. We're paying monthly for 10 years, so that's 12 months in a year, so that would be 120 payments. Our interest rate, now as you recall, it was 1% per month, so the interest rate is 12% per year. Now the present value, this is interesting. The present value to us is negative because we owe that money. So that would be minus $35,000. So that's the present value, and we're going to pay that down to 0. Payment we don't know yet. That's what we're trying to find out, so we leave that alone. Future value. Think for a minute. What is that going to be? It's 0. When we pay off the loan, the value is no longer has any money. It's a 0 loan. Payments per year is 12. So we're going to go ahead and increment that up to 12, 11, 12. Let's scoot down. Now that one automatically shows up as 12, so we're good there. Let's go scoot back up. We want to get into payment. Okay, so now with the cursor in the payment field, you notice down below it says press enter to calculate payment. So I'm just going to go ahead and hit enter, and there we go. $502.15. So that's our payment. Now that's super easy. And just to know, when you have a loan like this, at the end, on the last payment, they're going to make an adjustment. You can tell it's going to be like this one. If we round it up to 15 cents, once we've made our 120 payments, we will have paid a little bit more than we need to. So after the 119th payment, the bank will send you a different statement, and they'll say, here's what you pay for your last payment. So there you have it. Now that you've watched the video, jot down some notes, some questions, or a quick summary of the lesson. You can also re-watch the portions of the video that challenged you the first time. If you enjoyed the video, please click like. If you'd like to help me grow my YouTube channel, please click subscribe.